In this section, we'll be going over SheetCam. SheetCam is your CAM software that will be writing your toolpath, also nesting, and creating the post-processor, and running the post-processor to create the file to send to your machine to be cut. To load a file into SheetCam, we'll come over to Parts, and by right-clicking, I will go to New Part, and then search for the DXF that I would like to load. The next step will open up your drawing options. The drawing position selects where your file will be loaded onto your sheet. Preferably, we would like this in the lower left-hand corner. By selecting OK, your part will be loaded. To create layers in your drawing, we will go to the Edit Contours button. From here, we can hover over top of the area that we would like to have a layer selected on. Right-click it, and we'll go to Move to Layer, New Layer, and this we can name This will create a second layer, or possibly even a third layer, depending on what you're looking to do. SheetCam also has the ability to provide nesting. To begin with nesting, we will want to set our material size. To do that, we will go to Options, Job Options, and enter in our material that will be nested. As you can see here, I have two colors, a gray and a maroon. The gray is the bed size of my table. The maroon is my sheet size. This is important when nesting the entire sheet. To begin nesting, we will go to the nesting icon, select that. By right-clicking over the material, from here we are able to move our material by either using the arrow keys or the comma and period keys to rotate the part. You can also select it by left-clicking and holding and moving the part. To nest, we will right-click. Duplicate will duplicate the part one time. Multiple will multiple duplicate until the escape key is pressed. Or you can select Array Parts to automatically nest. In the array area on X2 and Y2, we will enter our sheet size and select Fit to Material. And that will nest our entire sheet. Duplicating the part will duplicate it just one time. Multiple duplicates will allow the part to be duplicated infinitely until escape is pressed. Parts can also be spaced apart by entering in a spacing on the X and the Y and entering Fit to Material. Your parts will now have that selected gap between them. When nesting parts, it's important to have your first part always selected before performing any jet cutting operation. With your first part selected, all other toolpaths will be written to the other parts. Once you have finished editing your part, you will need to create a jet cutting operation to create the toolpath. To do that, we'll go to Operations and Jet Cutting Tool. From here, we'll select Outside Offset and the layer we want to use. In this case, we'll be using the cut layer. This will be the layer that we're going to plasma. We'll also set up our consumables and our sheet thickness. That will automatically load the speeds and settings for your plasma. We'll have reverse cut direction checked. For your path rules, you can go with none. Your Halo system will automatically set the path rules for you. We can also set up our lead-ins and lead-outs. In this case, we'll be running an arc with no lead-out. You can also loop the corners. This is really handy when you're working with thicker metal. With the loop enabled, you'll be able to continuously move your torch without it stopping and changing direction. It does provide a better cut quality and better edges. We will start at the center of the circle smaller than 2 inches, and our length will be 0.2 inches for our lead-in. So I'll select OK. You can see my toolpath has been written. If I do want to change the lead-in, I can come over here to Edit Start Point, and I can change my lead-in where I would like it to be. Now that our plasma toolpath is written, we will continue on by selecting in the Operations Jet Cutting tool. And this will be setting up the scribe. So we will go No Offset, select our layer. For our tool will be 101 Plate Marker, and no lead-in. Here we can select OK, and our plasma toolpath will be written along with our scribe toolpath. For our peck piercing toolpath, we will go down to the Create a New Drilling operation. Select that. Select our layer. And hit OK. Now we are able to write our post-processor. To do so, we'll go to File, Run Post-Processor. Select where you'd like that file to be saved at. And now we can move on to CNC. So here we have the cartridges we'll be using with our Hypertherm Sync 65. We'll have the fine cutting, the 45 amp, and the 65 amp. We'll also be using our ohmic clip that will be clipping to the tip of the consumables, opening one up. You can see that the consumables are all in one. They simply just screw up into your mechanical torch. RF reader is inside. You also have your electrode and shielded tip. The tip will work about the same as usual consumables. You'll inspect your shield, make sure that's clean of debris. Make sure that your tip is nice and rounded, not deformed, not egg-shaped. The rest will be taken care of by Hypertherm. The sync technology will actually shut this consumable off at its end of life. To run the ohmic sense, we'll simply just take our clip, mount that to our consumable. Now we'll just simply put our wire onto our cartridge, put it to use.